Slides. Okay, so in this module, we'll be talking about VPNs. Okay, everything related to VPN. The actual module is going to be SVPN, implementing secure solutions with virtual private networks. Now, before I talk about that, just a little brief about the CCNP security part. Okay, so if you guys are not aware, CCNP has been, or Cisco certifications have been revamped. Okay, now if you have to do a CCNP in any technology, you basically only have to do 2 exams. Okay, previously it used to be 3, 4, 5 exams depending upon which track you do for CCNP. Now it's just 2 exams. Okay, one is a core exam, which is the mandatory exam. Okay, once you clear the core exam, you get a specialist certification as well, and then you are also eligible to sit for the CCI lab. Okay, so there's no more CCI written exam anymore. Okay, now you can do the CCI, or you could do one of the concentration exams as well. Okay, so core plus concentration, 2 exams that awards you the CCNP security. Okay, now the core exams, they are they don't go in depth. Okay, they cover a broad range of topics. Concentration exams are meant to be very specific product or technology based exams. Okay, so when we talk about from the perspective of CCNP security, the core exam is your 350701 S score. Okay, this really talks about everything from the perspective of, let's say, network security, cloud security, analytics, VPNs, AAA, ICE, content security, multi-factor authentication, SAML, okay, SSO, and some of the other things that you might not have ever heard about those, or maybe never have experienced, never got to work on those. Okay, so the S score covers all of these topics in a much more broader way. Okay, so you won't really be asked about in-depth configuration or troubleshooting aspect. Okay, so this is your mandatory exam. And then you have to do a concentration exam as well. And you have lots of concentration exams available basically for you. Okay, and you have to do only one. So you could do as many as you want, but for the CCNP, you only want to do S score and any one concentration. Okay, so I'll just go over them. So these exams, they cover products or technologies in much more depth. Okay, right from design, implementation, troubleshooting aspects. Okay, so for example, the SNCF, this covers the next generation firewall. Okay, this is your ICE, AAA. This is your email security. This is your web security. This is the VPN. This is what we will be covering in this module. This is your security automation. And this last one that you see that I've put it in green, this is a new exam that Cisco has introduced, maybe a couple of months ago. This is around user and endpoint security. Okay, so this is a very interesting exam here, because it covers a lot of topics which a lot of people might not have even experience with technology, and these are technologies which are required nowadays in the real world in deployments. Okay, so for example, things like SASE. Okay, SD-WAN on-box security, Umbrella, DNS plus your SIG implementation. Okay, endpoint security, EDR solution, XDR. Okay, things like a threat response, visibility and assurance. So this is a pretty cool exam, and not as of right now. So it's been only out for some time. The content, I mean, obviously don't have the content yet developed for it, but it could be. In the future, we might do specific trainings, sessions for this content alone, because um, this is where the implementations, the deployments are going nowadays. Okay, you need to know things about SAML, SSO, right? How do you do zero trust? What is Cisco safe architecture? Okay, multi-cloud policies. What do you, or how do you implement, and what's the use case for CASP, Cloud Access Security Broker? Okay, if you are in the data center, how do you do secure workload? Or how do you implement tetration? Okay, so a lot of these topics, and there are lots more, that is basically centered around this particular uh, thing. Okay, so this is going to be a pretty unique, pretty good knowledge-based training. Even if you don't do the certification, it will be good knowledge to have um, moving forward for the future. Okay, so this is what your CCNP security kind of looks like. So it's covering almost everything that Cisco has to offer around the security portfolio, and a little bit more. Okay. Now, from our SVPN perspective, that's the exam code. 30730. Okay, and this is version 1.1, which is basically the exam version. Okay, so it keeps kind of changing, keeps revising. Cisco is now doing quarterly revisions for their exams for the blueprint. Okay, previously we used to have multiple years used to go by before Cisco used to introduce any changes to their blueprint and the exams. Now it's much more frequent. Okay, so every quarter, every 2 quarters. So in an year, you could see an exam change or content change happening 4 times. Okay, so these are the domains that specifically cover the SVPN exam. Okay, site-to-site VPNs, very common uh, implementations. Okay, and you need to know VPNs not just from Cisco perspective, but from the perspective of any vendor out there, right? You pick up Juniper, HP, Palo Alto, Fortinet, everyone does VPNs. Okay, so core functionality, yes, you need to understand what VPNs are. So that's what we will cover from scratch, what VPNs are, what is an overlay, what do you mean by underlays, PKI, okay, very important, public key infrastructure. What is IPSec? How does IPSec work? What's the framework look like, right? When you hear keywords like ESP or AH, what's the difference between them? How do they do the encryption, and all that good things? Okay. Another important aspect is remote access VPN. These are typically for your remote workforce. Okay, or your hybrid workers. They might be working from home, from a coffee shop, from an airport lounge. They could be anywhere. Okay, you would want them to have access to your internal resources. So they could be VPNing into your infrastructure. Inherently, while we are doing, remember, SVPN exam is very troubleshooting heavy. Okay, so a lot of people, they fail this exam because they go into with the impression that they know how the configuration needs to be done. They know how to enable the debugs, missing configuration, that's good. But Cisco's focus on VPN is troubleshooting. Okay, so you should know the configuration. If you see missing configuration pieces in questions, you should know what configuration need to be added and why. Okay, so you need to know the logs. Okay, you need to understand how VPNs work from a Cisco's perspective. Okay, so make sure that you don't go into this exam with the impression that if you know the configuration, if you know how to set up VPNs, you'll be able to pass. Okay, you need to know it in depth. Okay, specifically logs, and a lot of questions typically should be around things like you see the configuration, there are some missing configuration pieces. Why would you add certain piece of configuration, etc. Okay, and in a moment I'll show you the blueprint for the exam so that you can also see why do we have that troubleshooting aspect coming in a lot. Okay, so what we'll cover or what you learn through training is types of VPNs, obviously, and these are the various types of VPNs that we would be covering. Okay, we will be talking about DMVPN, FlexVPN, GetVPN. A lot of you might not have even heard about these two VPNs in particular. Okay, Flex and Get. Previously, Cisco used to also test EasyVPN, or they could write it as EasyVPN. Okay, this is no longer used. Cisco does not kind of recommend this now. Okay, so you typically would want to know what are route-based VPNs, what are policy-based VPNs, how do you implement them, right? What the configuration looks like, what do the logs look like, what is the functionality, okay? And then obviously you have DMVPN, which I'm pretty sure a lot of you must have heard about, okay? So you would see this as part of CCIE as well, CCIE Enterprise, EI, okay? They don't test you as much as on the enterprise infrastructure, but you still need to know the three phases, phase 1, 2, and 3, right? What's done in each of them and why each of them was used. So for example, why was phase 2 implemented, right? When you already had phase 1, right? Why was phase 3 implemented when you already had phase 2? So you need to understand the differences between those phases as well. And then obviously you have FlexVPN. If you are in a service provider environment, you would typically see GetVPN being utilized. Okay, so this is mostly a Cisco-centric VPN. Most of them are. Okay, for example, DMVPN is Cisco only. It's Cisco proprietary. Okay, similarly, Flex, Get. Okay, and then obviously we would be looking at a lot of the troubleshooting aspects of the exam as well. Okay, so we'll be looking at logs, configurations, making you understand how things work, what configuration, what configurations are being done to achieve what specifically. Okay, so this is the training is going to look like. So it's going to be somewhere around that 25 to 30 hours mark. Okay, maybe 1 or 2 hours up and down, doesn't really matter. Okay, but that's going to be the amount of time that you would need to get done with uh, the content. Okay, Any questions anyone has before I move on and show the blueprint for this, so we can understand what all Cisco is looking for from the exam perspective? Okay.
No, sir. We didn't have an idea. I just joined, so
All right, no worries. It's fine.
just yeah, okay. Thank you.
Right. So you can obviously, everyone should have access to this. Okay, so you can go to Cisco Learning Network, and then under the certifications, you have CCNP Security, and you should be able to access the exam topics for XVPN. Okay. Now, within this, if you're going to see what all Cisco is asking you to know, okay, and whenever you try to look at a blueprint, it's very important for you to understand. That's how you know what you will be tested on. Okay. So for example, they want you to be able to implement DMVPN. Okay. They want you to be able to implement FlexVPN, but only using local AAA. Okay. So you don't need to integrate or know how to integrate something like maybe Active Directory. Okay. So they only want you to be able to do the authentication piece within FlexVPN using the local database. Okay. Similarly, when we talk about remote access, they want you to know AnyConnect, VPN, okay, clientless, and you should also know, obviously, FlexVPN. Okay, and you can see the percentage, 15%, 20%. Now, if you're going to look at the troubleshooting section, it holds 35% weightage. Okay, that's the highest across all the domains. So you should know how to troubleshoot IPSec, right? You should know how to troubleshoot DMVPN, FlexVPN. You should know how to troubleshoot remote access VPN. Okay, so it's going to be a very troubleshooting heavy exam because of this. And the last piece that we have here is your secure communication architecture. Basically, the same thing. It's just that they want you to understand the components when you implement GetVPN or FlexVPN or maybe DMVPN. Okay, basically, you should be able to identify. So they might give you a diagram with configuration and everything, and they might ask you what sort of a VPN it is. Okay, so you should be able to identify the components, identify the technology based on configuration outputs for site-to-site and remote access VPNs. Okay, so you should know how to design VPN solutions, both site-to-site and remote access.
So do you have a different device for VPN or just it is a server, a service?
It's basically a service.
Okay.
Okay,
Something like GetVPN, FlexVPN are like service, right?
correct.
In which device, sir?
Could be on a router or could be on firewall.
Oh, okay, thank you.
Okay, so for example, you have ASA on router. This is your firewall. Okay, so that's what your blueprint kind of looks like. Okay, so anytime you're trying to do an exam or anything, you should come into the blueprint and see. Okay, your main emphasis should be on implement. Okay, whatever you see as implement, you should know how to configure. You should know the configuration, and you should know if I give you a configuration output where you have a missing configuration, you should be able to fill in those blanks. Okay, which you can see here. They want you to do. Okay. So that's a blueprint. Again, this is accessible. You can access this um, on the web. Okay. Let me just bring up the Blackboard and we'll go over some of the very basic foundational things. And the way that my sessions go, I don't really like using slides. Okay, so it's typically going to be either a whiteboard or a blackboard. Okay, right. So VPNs, short for your virtual private network. Okay, now the main premise behind this is to expand your knowledge on VPNs. Okay, again, it is very important. One of the very important um, aspects or features or technologies when you talk about security are your VPNs. Okay, and the thing about VPNs is VPNs are based upon complex protocols and algorithms. Okay, so if you've never worked with IPSec, if you've never worked, or if you don't know things like underlay, overlay, things of those nature, it can be a little bit complex. Okay, so the main premise behind this class is to um, give you the theory and the details of VPNs, as well as give you step-by-step configurations of how you would implement something, and then obviously show you the logs and everything that go behind the different um, mechanisms of VPNs. Okay. Now, I'll do a very brief theory, if you might say, behind VPNs, just to give you an insight of the different types and the ways that Cisco implements VPNs and what are the different categories of VPNs. Okay. So in the slide, I showed you policy-based VPNs and route-based VPN. Okay. Now, policy-based VPN, you typically call them, or you typically implement these with native IPSec. Okay. If you ever implemented, let's say VPN, where you made use of crypto ACLs or crypto map, okay, if you ever heard those terms from Cisco's perspective, from ASA's configuration perspective, that is a policy-based VPN. Okay, policy-based VPNs are supported on firewall, okay, and routers. Okay, so using policy-based VPNs, you can implement site-to-site VPN. You can implement hub and spoke VPN. You can implement remote access VPN. Okay. In contrast, you obviously have route-based VPN. Now, route-based VPN can be implemented in two ways, and you must have heard about these terms. One would be GRE based. Okay, so anytime you see any VPN which makes use of GRE, that is a route-based VPN. Okay, generic routing encapsulation. Or you could make use of virtual tunnel interfaces, VTI. Okay, now with crypto or with policy-based VPN, you don't need to implement IPsec separately. It's native, which basically means when you do the configuration of policy-based VPN, you are implementing protection or you are implementing IPsec. With route-based VPN, when you do GRE or when you do VTI-based, you're just creating tunnels. You're not creating secure tunnels. Okay? Because of which, when you do GRE and VTI, you have to also implement them with IPSec. Okay, so if you just configure GRE or just configure VTI, there's no protection. Okay, you just have tunnels. That's it. If you have to do the protection, you have to make use of GRE. Sorry, IPSec. Now, either of them, okay, either of them, they can be used to again implement site-to-site VPN, or you could do hub and spoke, but no remote access. Okay. A very common example of route-based VPN is DMVPN. Okay, so if anyone has experience with DMVPN, DMVPNs you make use of GRE, a modified version of GRE, which we call as MGRE. Okay, when we'll go over the DMVPN section, we'll explain what MGRE is, how it's different than GRE. Okay, but anytime if you're implementing DMVPN, you basically make use of route-based VPN, which is based on GRE, or which are GRE based. Now, route-based VPNs, they are supported on routers only. They are not supported on firewalls. Basically ASA. And I'm writing ASA here because if you looked at the blueprint, Cisco only asks you to be able to know ASA and router. Okay, you need not know next generation firewall, Cisco next generation firewall from VPN perspective. Okay, so ASAs, they don't support route-based VPN, but Cisco's next generation firewall, it supports route-based VPN, so that's the exception. And it implements VTI, not GRE. Okay, but from an exam perspective, you basically only need to know ASA. From a real world perspective, you should know ASA as well as next generation firewall. Okay, and here, when you implement a DMVPN, you are basically implementing a mesh VPN, or you could call it a multi-site VPN. Okay, the final mechanism or the final way of doing the VPNs, basically, it is your SSL-based VPN. Okay, these are supported on both ASA and routers. And the use case for this is basically you would implement this for remote access VPN. Okay, and I should say client-based. Okay, so from a remote access VPN perspective, you could implement remote access in two ways. You could do client-based, or you could do clientless. Okay, when I say client, basically means some piece of software that is running on the user's device, okay, which from Cisco's perspective would be AnyConnect. Or now the newer generation of this client is basically called as secure client. Okay, so this client basically establishes VPN tunnel from the end user's device to wherever the location is, to a router or to a firewall. Clientless, again, it does not make use of client, it just utilizes a web browser for establishing the VPN tunnel. Okay, so that's majorly the difference between the two. Okay, so client-based VPNs, again, they have lesser functionality in comparison to client-based VPNs. Okay, so when we do the VPN and everything, we'll see the clientless as well. We'll see the client-based as well. Okay, so we'll see both of them in action. Okay, but my main focus is going to be on the client-based because that's what typically you would be implementing in the real world out there in your real deployments. Okay, so this is majorly what all we are going to talk about, what all we are going to cover in much more detail with respect to VPNs. Okay, so just talking about a little bit about the policy-based and the route-based. Okay, that's where a lot of confusion really is. So policy-based VPNs are basically your traditional VPNs. These are your traditional IPSec VPN. And don't worry if you don't know IPSec in general, okay, what IPSec is, what the framework is, how does it really function or operate? We talk about that in much more depth. Okay, for now, I'm just trying to give you a very brief of what we will be talking about, what all we'll be covering, and some of the differences between the different VPN types. Okay, so these are my traditional IPsec VPNs. Right there, again, like I said, they're supported on Cisco firewalls, ASA firewalls, and Cisco routers. Okay, now the way, at a high level, the way that this VPN works is you configure what we call as crypto ACL. Now this ACL matches what we call as interesting traffic. And what is an interesting traffic? Interesting traffic is anything, or interesting traffic is the traffic that we want to encrypt and encapsulate. Okay, so on the router or on the firewall, we configure the ACL. We say, hey, if the traffic is going from subnet A to subnet B, this traffic needs to be encrypted, needs to be sent over the VPN tunnel. So within the crypto ACL, you would define this, permit traffic A to traffic B using an access list. Okay, so since this ACL is being used, it's just like a regular ACL. Why we call it a crypto ACL is because this ACL is used to match the interesting traffic. Okay, it's not being used to permit or deny traffic coming in or going out of the firewall or the router. Okay, it's basically used to tell the VPN engine or the VPN process that this is the traffic that you need to encrypt. Okay, so traditionally, with these traditional ones, IKE version 1 used to be used a lot. Nowadays, for most deployments, you would be making use of IKE version 2. Okay, Internet Key Exchange Protocol. Again, if you don't know what it is, don't worry. Okay, it is part of IPSec. So when we'll discuss IPSec framework in depth, we'll talk about IKE version 1, IKE version 2, things like what an ISACamp is, what security associations are, okay, and then things like IK version 1, IK version 2, okay, things like your ESP, authentication header, right? What is the CIA? How do you do encryption, integrity, hashing, all of that good stuff. Okay. So like I said, VPN is a combination of all of these complex algorithms and protocols. Okay. The configuration piece is the easier part. Okay. Understanding IPSec and a lot of these terms and the algorithms and protocols is the more difficult part. Okay. That's your policy-based VPN. Okay. So it supports both IK version 1, version 2. This is the older one. Okay. In some cases, you could call this obsolete as well. Okay, a lot of newer devices, newer routers, newer firewalls, they don't even support IK version 1. Okay, now talking about route-based VPN in comparison, why it's called route-based VPN? Because it makes use of these layer 3 interfaces, tunnel interfaces, to build the tunnel. Okay, so it's called route-based VPN because it makes use of special virtual layer 3 interfaces, which you call as tunnel interfaces. Okay, and you basically make use of routing. Okay, so this policy-based VPN, it does not use or implement or support routing. And when I say the routing, I specifically mean dynamic routing. So if you have to populate the routing table, if you have to provide reachability to networks, you will basically make use of static routes or static default routes. Okay, so in which case, a lot of times you would find policy-based VPNs to have a complex configuration. Because there are lots of moving parts to, or there are lots of pieces to the configuration. Okay, and the primary thing is they do not support dynamic routing protocols. They do not support anything that is non-IP. For example, multicast. Okay, there is limited QoS support as well. Okay, but a good thing is it can be used on both routers and firewalls. Route-based VPNs are routers only, or are supported on routers only. Okay, utilizing GRE or VTI, you can make use of routing protocols. You can do OSPF, EIGRP. There is support for that. You can also do non-IP protocols. There is support for multicast. QoS is fully supported. Okay, and the configuration is much more simplified. Okay, anyone has any questions?
No, sir, we are getting the point clearly.
Okay. Now, the last thing that we'll talk about before we end the session for today is my remote access VPN. Okay, so you can call the SSL based VPNs as remote access VPNs as well. Okay, typically this would be a much more better term to use to explain the SSL based VPNs because they are meant to provide remote access. Okay, remote access to users that will be sitting at home, again, anywhere remotely. Okay, and when you have a client, the user must have some sort of a Cisco software. Okay, in this case would be either AnyConnect or Secure Client installed on his or her computer, which will enable a secure communication with something like an ASA or router. Okay, so you could have this user here. Okay, he's sitting somewhere on the internet, maybe, right? This is maybe your, let's call it your data center. Okay, and there is, let's say, a router at the edge, right? So this user using his laptop or his computer is going to establish a tunnel with this router. It is again doing the same thing. It will still do IPSec. Okay, so the base functionality of VPNs is your IPSec. Okay, so it will still do IPSec. It will still do things like IK version 2. But rather than two routers creating the tunnel, it will now be this piece of software sitting on the user device that will now be responsible for creating that tunnel with a router, or it could be a firewall as well. Okay, and then depending upon how you want things to be, one additional thing that typically you configure or is required in remote access VPN is how do you want this tunnel to behave? Okay, so a lot of time organizations say all the traffic needs to flow over the tunnel. Okay, it could be local internet traffic, or it could be this user trying to access resources in the data center. Okay, this is typically called as a full tunnel. Whereas sometimes organizations want local traffic or the internet traffic to route out locally, not go over the tunnel. Okay, so this TC, it will just use its local network to go to the internet. And any corporate traffic will go over the tunnel, VPN tunnel. Okay, so this is basically called as split tunneling. Okay, so typically organizations don't do split tunneling because of security reasons, right? They want to see all the traffic or anything or everything that this device or this user is accessing. Okay, typically would be the case if this user has a corporate device, okay, a corporate managed or an organization managed laptop, mobile phone, etc. Okay, so anytime they do VPN, all the traffic goes across the VPN. So even if he's trying to access, let's say, Facebook, that traffic will still go through the data center. Okay, so it'll go in the data center, it will come out through the data center, through the data center's internet breakout. Okay, so you'll see how you configure basically full tunnel versus something like split tunneling. All right, that's your client-based. Okay, and another advantage of client-based is all network resources can be accessed remotely. Okay, so pros, all network resources, let's say applications, can be accessed remotely. Okay, with clientless, like I said, clientless was the very first way to implement remote access, okay, in which the users can make use of just the web browser to establish the VPN tunnel. Okay, so there's no need for any software or any other client to be installed on the user's device, just the web browser. But the con is that there is limited access allowed. And obviously, there are some additional functionalities that you can do with the help of a client. Okay, for example, a very common one is posture assessment. Okay, which you can do using the client, which is in short, which is just making sure that the device that is connecting to meet your organization's InfoSec policy. Okay, which could be things like, let's say a new Windows patch came out. Okay, the patch is installed on the machine or on the end user device. Maybe they're running some sort of an antivirus. The antivirus should have the latest signatures installed. Okay, and various other things that you can check through posture assessment. Okay, so if anyone here has experience with Cisco ICE, you would understand what posture assessment is. If not, I've kind of given you a very brief of what it does. Okay, so it's just a way or another way to enhance security of any device that is trying to connect to your network. Okay, so with clientless, you don't get all of this functionality. Okay, clientless just is there to offer very limited access. That's it. Nothing else. Okay, a lot of times you can use clientless VPN the first time that the user tries to connect. He can then use clientless VPN to download the client and then start using client-based VPN. Okay, that's how we will see the implementation in the lab as well. Okay, so it could be a scenario where, during, let's say, something like we had uh, the COVID pandemic, right? So we could not have physical onboarding, right? So what organizations would do is they would still send the resources, company laptop, okay, to the user, which was not configured at all. Now, when the user first time he would connect to the company's website through something like a web browser, doing a clientless, at that point in time, through the browser, the client and other resources would be downloaded. They would be installed, and now the user can utilize the client to connect, to establish a VPN tunnel, and get full access to whatever he needs to do over that VPN tunnel. Okay, so that's a very common implementation, a common way to do the implementation. If, however, you nowadays, for example, all the onboarding and everything is being done physically, a lot of cases virtually, but you still have the IT teams and everything working through um, from the office. So in that case, nowadays, all of these clients and everything are being kind of installed already. Okay. Another use case for the client list would be, let's say we are running a client and you want to push maybe an update. Okay, maybe a new version of the client came out, or maybe you want to change some sort of a configuration, maybe change the profile or the policy on the client. You can make use of clientless. Okay, I could write this as clientless web VPN portal. Okay, you'll see when we do the implementation. It looks like a portal. It gives you an option to download the client. Once the client gets installed, you then use the client to do client-based remote access VPN. Okay, and at which point in time, you basically can get full network connectivity. Okay, this does not offer full network connectivity. All right. So those are your different ways in which you do VPN. I've not discussed DMVPN. Obviously, we're going to cover that in much more detail when we'll reach that topic for DMVPN. Okay, but it is a subvariant of route-based VPN. Okay, it makes use of GRE, a modified GRE version, which we call as MGRE or multi-point GRE. Okay, which you will understand why it's called multi-point and how it establishes mesh VPN or multi-site VPN. Okay, so we'll be covering all of its three phases and understanding what each phase offers and why do you implement the next phase, what were the limitations of the previous phase, why the next phase was developed and designed, and how do you do current deployments when you do the new deployments for DMVPN, how do you implement those. We'll see the functionality, logs and everything, because again, um, the SVPN's core is your troubleshooting. So you should know the logs. You should see how things are working, right? What do you see in the logs? How the tunnels are created, and all that good things. All right. I'll stop now and take any questions if anyone has. Okay, so I think that would be it for today. Okay, you can get more details from the team, from the networking team about the timings and everything. Okay. So if no one has any questions, I think we can end this session.
Yes, sir, we can end. Thank you for the great session.
Thank you.
All right. Thanks, guys. See you in the class.
Thank you so much.
Have a good time.